In October 1999, a supercyclone devastated India's eastern coast. It hit with 260 km/h winds and 10-meter tidal waves that surged 20 kilometers inland. It raises a difficult question. How does something completely invisible possess the physical power to level entire cities? The atmosphere is a massive, heavy blanket of gases physically surrounding the Earth, pressing down on everything it touches. This blanket is comprised almost entirely of just two gases, 78% nitrogen and 21% oxygen. Far from an empty void, this mixture is a solid physical structure, shielding the planet from the harshness of space. This shield is divided into 5 vertical layers. The bottom, troposphere, is where we live, containing our air and weather. Above, the stratosphere's ozone blocks solar radiation, while the mesosphere burns up meteorites. The uppermost, thermosphere and exosphere, gradually thin into the vacuum of space. These layers form a static shield, but the troposphere at the bottom is a churning thermodynamic engine waiting for a spark. The fuel driving this atmospheric engine is incoming solar energy, a process known as insolation. Because the Earth is curved, this energy hits the equator directly, while striking the poles at a weak, glancing angle. This uneven heating triggers a change in air pressure, the physical weight of the atmosphere pressing down on the surface. Heated equatorial air expands and rises, creating a low-pressure area associated with cloudy, wet weather. Conversely, cold polar air is dense and sinks, creating a high-pressure area, bringing clear skies. The sun's uneven heat transforms the planet into a restless landscape of heavy high-pressure and light low-pressure zones. Nature seeks balance, so the atmosphere is constantly trying to equalize these pressure zones. Wind is simply the mechanical result of heavy, high-pressure air rushing horizontally to fill the voids left by low pressure. As this air moves, it acts like a massive sponge, evaporating and carrying water vapor as it travels over oceans and land. When this moisture-heavy air is forced upward, either by heat or by hitting a mountain range, it begins to cool. Cooling air loses its capacity to hold water, causing that vapor to condense into heavy droplets that fall as precipitation. Every weather event is just this single engine: heat, pressure, wind, and moisture, working to find equilibrium. Nitrogen and oxygen comprise 99% of our air, providing the physical medium we live in and the oxygen we breathe. However, a trace greenhouse gas called carbon dioxide serves as the thermostat for this entire global engine. Carbon dioxide traps heat radiating off the Earth, naturally keeping the atmospheric engine running at a warm, livable baseline. Today, human activities like burning fossil fuels are injecting billions of tons of excess CO2 into this system, upsetting that baseline balance. This added CO2 traps more heat, essentially turning up the power on the Earth's thermodynamic engine. As the system heats up, the low-pressure zones at the equator expand more aggressively, while the high-pressure zones at the poles become more unstable. This creates deeper, more violent pressure differences that the atmosphere must correct. These corrections manifest as stronger winds, unpredictable rainfall patterns, and the rapid melting of snow and ice caps. This melting ice eventually flows into the oceans, raising sea levels and causing devastating floods in coastal areas. Global observers are now tracking these anomalies as the atmosphere reacts to its changing chemical makeup. The atmosphere is a finely tuned thermodynamic machine, and protecting its balance is now the most critical requirement for our survival.